Okay, so in this video, we're going to start looking at logarithm equations, all right, or logarithmic equations. Now, there's a couple of little techniques for how you might go about solving them. The first way that I'm going to show you is I'm going to take the logarithm statement and I'm just going to rewrite it in exponential form because a lot of times that'll give you enough insight in how to solve it, all right? So I've got log base x of 8 is equal to 2. So in exponential form, x would be my base, 2 would be my exponent, and then this is equal to 8. All right. So the answer for this is, not going to be that bad to solve. You would take the square root of both sides, and you would get x equals plus or minus root 8. But we can only use the positive version in this case. Okay, and that's just because you can't have a negative base. Your base always has to be between 0 and 1, or it's got to be greater than 1. Yeah. I'll go ahead and apply that same rule here, and then I'll go back and show you the other way to think about these. So if I rewrite it in exponential form, it's going to be 4 to the third power is equal to x, and so this is just 64 is equal to x. There you go. Not much work required. All right, got those two solved. If I did the same thing here, it would be 3 is my base to the fifth power is equal to 2x plus 1, and then you just have a short linear equation that you would have to solve. 3 to the fifth power is 343. All right, subtract 1 from both sides. And then you're going to divide by 2. What is that? 150 plus 21, 171. Yep. You get 171 is equal to x. All right. Now, the other way that's pretty common for solving logarithm equations, instead of rewriting them in exponential form and then solving, is you're going to take the original and you're going to exponentiate it. All right. So before, when we had exponential equations like 2 to the x power is equal to 10, we would take the logarithm of both sides in order to get this exponent down. All right, like we would do log base 2. All right, log base 2 of 2 to the x to both sides. And then this logarithm part and this base would just cancel each other out. Well, I'm going to do something similar, but since I already have the logarithm, I'm going to put a base under it. All right, I'm going to look at x is my base. I'm going to look at x to the log base x of 8 is equal to x to the 2. All right, so I'm exponentiating both sides of this equation. I'm doing x to the power of what was already there. All right, and then what's going to happen is the log base x and this x are just going to undo each other, and so you're going to be left with an 8, and then on the right hand side you'll be left with the x squared, right, just like we had earlier. So what I would do for this one is I would do 4 to the power of all this stuff and 4 to the power of 3. The 4 and the log base 4 are going to undo each other. They're inverses. And so you get x equals 4 to the power of 3, which was 64. All right, this is going to be a more common way that you see people solve logarithmic equations. They're going to exponentiate both sides. So I'll do 3 to the power of all this stuff, and I'll do 3 to the power of 5. That's going to give me 2x plus 1 on the left-hand side and 343 on the right-hand side. and then you see it's going to work out exactly the same. So it probably feels a little unnatural at first, but eventually it's going to be the way to go. All right, so for this top one, let's see here. This one is just going to be a nice number. So I'm going to simplify that, and then I'm going to move, and then I'm going to treat it like a linear equation. I'm going to try to isolate the part that has my logarithm with a variable. I'm going to try to get that part down to just to itself. All right, log base 2 of 16, that's equal to 4. All right, because 2 to the 4th is equal to 16. We'll subtract 4 from both sides. We get negative 3 log base 2 of x is equal to 15. Now I could take this negative 3 exponent, or negative 3 on the outside, and put it back in the parentheses as an exponent, and then and then exponentiate it. But I'm just going to divide by negative 3, because this negative 3 is connected by multiplication. So I'm just going to divide to get rid of it. It's going to leave me with log base 2 of x is equal to negative 5. And now I'm going to raise, I'm going to do 2 to the power of on both sides. I'm going to exponentiate both sides. So I'm going to do 2 to all of this and 2 to the negative 5. Leaves me with x on the left, and whatever 2 to the negative 5th is my answer. All right, this comes out to be 1 over 32. Excuse me. All right, last example here. Let's see here. I've got 2 logarithms, and both of them are base 6. What I'm going to do here is I'm going to get log base 6 on both sides and then exponentiate it. So I need to put this 2 back into the parentheses. Right? Log base 6 of 3x minus 1. So if this is going to be log base 6 of 4 to the second power, which is just log base 6 of 16. And hopefully you can see what's happening here is that on the left-hand side, I only have log base 6 of this stuff. And here I have log base 6 of this stuff. So these two things that are in the parentheses must be equal to each other. All right. What you do is you do 6 as your base. You exponentiate both sides. And that gets rid of the logs. Okay. Plus 1 on both sides. Divide by 3. And that is our answer. X equals 17 thirds. All right, I'm going to go ahead and show you how you can check your answer. You could plug 17 thirds in for X here and then use the change of base formula. I want to go ahead and show you where you can do the this fancy logarithm expression here, where you can type those in. All right, we're going to go to math, log base, so math, and then I went up until I got to log base. All right, we're log base 6, and I'm going to do 3x minus 1. There we go. And then I'll type in the right-hand side, 2 log base 6 of 4, and it should be a match. Yay! There you go. So this just gives you another way of typing in or evaluating little expressions like that, rather than just using the change of base formula every time.